Hi guys, in this video we're going to take a look at solving trig equations. Now, the good news is you've actually already done this, you just didn't realize it. So in this first section we're going to work with fairly straightforward trig equations or trig functions to solve. Your homework, this is for spring of 2020, is going to be here on 3 through 8 plus solving these four without a calculator. Okay? And so just to kind of get you back in the mindset and remembering what things are, this first question here, for tangent of 2x, what does the 2x represent? Just pause and think about it a second. Hopefully you're thinking tangent of an angle. 2x represents an angle. And if you wanted to get a little more technical, you could say the angle, and we're interested in, well, just 2x itself is just the angle. Tangent then tells me I'm interested in the y value over the r value for that angle on a given circle. I said that wrong. Y value over the x value. Which actually takes us to this next question, number 2. Knowing these definitions is going to be really helpful here. So sine theta, what is that in terms of x, y, and r? Hopefully you're thinking y over r. Cosine, x over r, and tangent, y over x. Know those definitions forwards and backwards. Along with that, we want to think about which quadrants is sine positive, cosine negative, tangent positive, just knowing those. So if I put the definitions together with these questions and we think about x and y values, x values in this quadrant are positive and y values are positive as well. And so you can think of x, y as positive, positive. So that means sine is positive in quadrant 1. Where else are my y values going to be positive? Because remember, my radius is always positive. Well, in quadrant 2, my y values are positive. X values are negative, y values are positive. So quadrant 1 and quadrant 2. Where is cosine negative? Well, if you look, cosine is negative at x over r. R is always positive, so where is x negative is really what this question is asking. X is negative in quadrant 2. But we also see x is negative in quadrant 3. And then let's hit quadrant 4 real quick. X is positive because it's to the right, y is negative. And so that's quadrant 4. This asks, where is tangent positive? Well, tangent's y over x. So for that to be positive, we would want a positive y divided by a positive x, or a negative y divided by a negative x. So tangent is positive in the first quadrant, and also in the third quadrant, because a negative divided by a negative will give us a positive. So these two quadrants. And that's really kind of the foundation to what we're going to be looking at here. So first example, let's solve this equation. Solve cosine of x equals square root of 3 over 2. Now, hopefully you're seeing this and you're thinking, oh, those numbers are coming from a 30, 60, 90 triangle, right? So I've got 1, 2, square root of 3. 1 is opposite the 30-degree angle. This is 68. And you're seeing these numbers. And so we need to come up with an angle so that this is the cosine ratio. Well, cosine is x over r. So how can I set it up so my x is the square root of 3 and my r is 2? Well, let's think this through. If x is going to be the square root of 3, here to here is square root of 3, then my r has to be 2. Hopefully you're able to visualize this with this triangle. You're seeing this is the long side, so I need my short side to be up and down as 1, and this to be 2. And so we can think that through. That's a 30-degree angle, or in radians, that's going to be pi over 6. Ta-da, we're done, right? x equals pi over 6. Wrong. What do you mean wrong? We found it, didn't we? For this angle, it works. You're right. But it says on the interval from 0 to 2 pi. So if you think about this, from 0 to 2 pi, there's actually a second place where the cosine ratio is the square root of 3 over 2. And that's going to go back to these ideas. Cosine is x values. Where else is x positive? It's in the fourth quadrant. So if you look in this fourth quadrant, not quite where I want it to be. Fail again. There we go. Even though my y value is negative, my x value is still the square root of 3. And so if I look here, oops, didn't want to do that. All right. So let's do it in a different color then. So from here to here, this angle, theta, is also going to have a place where x square root of 3 over r2 gives me a value that's true for that equation. So what is that angle? Well, if this is pi over 6, this is negative pi over 6. If I go all the way around, 2 pi is going to be 12 pi over 6. So this must be 11 pi over 6. And so we have two solutions, pi over 6 and 11 pi over 6. Okay? Now, I'm going to change the directions on you. You didn't know we could do that, did you? So, solve cosine of x equals square root of 3 over 2 for all values of x. This is actually redundant. We don't actually need that. It could just say solve, and then we've got two solutions, but we need to give all the solutions. Now, what does that mean to find all of the solutions here? Well, I actually listed one earlier and mentioned it right here, right? If I go backwards, that would be negative pi over 6. That would be a solution. Now, some of you are thinking, wait a minute, this could go on forever. These are all just coterminal angles, and you're exactly right. Instead of going to just stop at pi over 6, what if I went all the way around the circle and back to this line? That would be 12 pi over 6 plus another pi over 6. 13 pi over 6 is also a solution. Let me take a look at this graphically, okay? So if we come back here, I've graphed this in Desmos. You can see I have y equals cosine of x there, and I also have y equals square root of 3 over 2. So anywhere where this red function crosses over with this blue function, we get an intersection. And you see this first value happens at pi over 6, just like we found on the circle. Pi over 6. Now some of you are thinking, hey, here's a way to cheat the system. Instead of using this and trying to solve, I'll just graph cosine of x and square root of 3 over 2. Just like I did here. And then I can just touch the graph, and I can find pi over 6 as my solution. And you could. And I'm not actually completely opposed to that, although I will probably test you on this idea as well in a different format and make sure you understand this idea. But knowing and understanding the graph is really helpful, because if you look, you can see all the solutions. We can see why there's so many solutions. Pi over 6, 11 pi over 6, we already found that one. 13 pi over 6, I mentioned that one. Come back here, negative pi over 6. 23 pi over 6, that's not one that we had, but if you can imagine just going around to 4 pi, which if I change that into common denominators of 6, that would give me 24 pi over 6, and then I just go back one, that's 23 pi over 6. So this is getting too much, right? It's going on, and we can keep sliding down, and we can find more and more solutions. Like, surely I don't want you to write all of these solutions. Well, I do want you to write all of them, but just not like you're thinking. Instead of just trying to write all of these out, what we're going to do is we're going to list typically the first two from 0 to pi over 2. We're going to say x equals pi over 6 and 11 pi over 6. And then we're going to write what at first seems like a complicated format. Let me explain it. Different language, huh? Okay, this is actually really useful. Take it a bit by bit. I'm actually going to start at the end here. K is an element of Z. What that means is that K is an integer, is really any integer. Okay, what's an integer? An integer is any positive or negative whole number. Okay, now if k is an integer, this says 2 times k times pi. Now, it might be helpful to think of this as 2 pi times k. What is 2 pi? Hopefully you're thinking, oh, 2 pi is just going around the circle, right? It appears that my screen has frozen. No. There we go. I don't know what happened there, but I'm glad it decided to work. 2 pi is just going around the circle. So if I find pi over 6 as a solution, and then I go around the circle, I'm going to get another solution. And so let's just say for a moment that k is 0. So pretend that k equals 0. Then this says that x equals pi over 6 plus 2 pi times 0, which is just pi over 6. Check, that's the solution we had. But what if k equals 1? Then x equals pi over 6 plus 2 pi times 1, which is pi over 6 plus go around the circle once. Check, that works. What if k equals 2? Hopefully you're seeing this. Pi over 6 plus 2 pi times 2. That's just the answer plus going around the circle twice. And that's a solution. And so no matter what k is, this will give me another solution. What if k is negative? Let's do that quick. What if k is negative 1? Then x equals pi over 6 plus 2 pi times negative 1, which is really negative 2 pi, which means I'm going backwards. So that means start at pi over 6 and then go backwards a circle. That's going to give me another solution, which in this case ends up being negative 11 pi over 6. And we can see, maybe you aren't convinced here, but if we go back to the graph, what is the solution back here? Do you see? Negative 11 pi over 6. Pretty cool, huh? So this little format, which is kind of complicated, but it really is going to give me all solutions that are coterminal with pi over 6. Now, if you didn't follow all of that, it's not the end of the world. Just know that when you're solving for all values or solving and it doesn't give you an interval, that you just tack on this 2k pi. Now, why do I have to do 11 pi over 6 as well? Well, you notice these gave me all of these solutions. This is going to give me 11 pi over 6 and everything that's coterminal with that. And so, at the end of the day, our final solution to solving cosine of x equals square root of 3 over 2 is going to be here. A lot of work. Let's do a quick summary, quick review. If we're doing this without a calculator, we're going to be looking for a special angle, and we're going to build that special angle. In this case, it was cosine x over r, so we built an x of square root of 3, an r of 2, and that gave us a y of 1. We knew that had to be a 30-degree angle, or pi over 6, and so that gave me one solution. I then had to think about where else on the circle do I have a positive cosine, and that's going to be in the fourth quadrant because the x values are down there, are positive as well. That gives me another solution, 11 pi over 6. But then we had to solve it for any value to get all of the points where these are solutions. And so we can't list them all out. So instead of listing them all out, we add this 2k pi where k is an integer or any integer. And then this gives me all the solutions that we're interested in. So I know there's a lot there. Feel free to pause it, go back and watch it again. If you really understand this deeply, you really, I think, can help yourself like kind of make solving trig